All right, we are going to continue on and finish up section 4.1. We are going to do some integrals of trigonometric functions. So I've lost where my numbers are, so we're just going to start over with number 1. The integral of 4 sine x minus 3 cosine x dx. So this is why I like trig. We kind of leave the other stuff alone. So remember, my integration symbol and my dx stay together for the problem, and then I'm going to not have them. They go away together when I do the actual anti-differentiation. So leave the 4. The derivative of sine x is negative cosine x. Then leave my 3. The antiderivative cosine x is, leave my 3, is just sine x. Don't forget your plus c. And we're done. That's it. So for number 2, the integral of the cosine of 5x dx is a little bit different. If your angle is not just x, that's when you have to worry about it. We like it when things are just x. So in general, the antiderivative of the cosine of something is the sine of it. So I'm going to have the sine of 5x. Well, as I said in the last one, that the antiderivative is the reverse of the derivative. So for the derivative, we would then multiply by the derivative of the angle. Because we are doing the opposite, we are going to divide by the derivative of the angle. Because the angle is 5x, the derivative of 5x is just 5. That's what I'm dividing by. Again, don't forget your plus c. We'll do one more. Number 3, the integral of secant x tangent x dx. Well, the integral of secant x tangent x is just secant x plus c, because the derivative of secant x is secant x tangent x. So we're done with that one. The last thing we have to do in this section are differential equations. So differential equations start off as dy dx equals 5 minus 2x squared. And you're told y of 1 is 2. So that's what you're given. When it says to solve the differential equation, that means it wants to know what does y equals. Typically when we want to solve something, we want y equals or x equals. Here we want to know what y equals. Because the top thing you're given is the derivative dy dx, we want to know the original function, so y equals. We need to find the antiderivative. So the antiderivative of 5 is 5x minus the antiderivative of 2x squared would be 2x. Add 1 to the exponent and divide by it. Don't forget your plus c. But here's the thing. We don't want to leave it as plus c. We want to know what the actual original function was. So over here in our information that we were given on the side, we know if we plug in 1 for x, we get out 2 for y. So when y is 2, 5 times 1 is 5, minus 2 times 1 cubed is 1, third plus c, which means 2 equals 4 1/3 plus c. So I can solve this for c fairly quickly. Subtract 4 1/3 from each side, and we get c is negative 2 1/3. Well, now that I know my original function and I know what c is, I can put them together for my final answer, which would be y equals 5x minus 2x cubed over 3 minus 2 1/3. And that's the final answer. So we don't want any variables except for x left in our final answer. All right, we can do one more of these. So now, if we are told dy dx equals 4x plus 9 and y of 0 equals 1, we can solve this. We can say y equals 4x squared over 2, add 1 to the exponent and divide by it, plus 9x plus c. But now I need to solve for c. So I'm going to plug in 0 for x and get out 1 for y. So I get 1 equals 0 plus c, or c is 1. Now that I know, oops, not that, my original function, now that I know my original function is here, and I know my c value, I can put it together. And make sure you reduce. So 4 over 2 is 2x squared plus 9x, and I now know that c is 1. So this is the final answer that I'm looking for. Sorry about that. So 2x squared plus 9x plus 1. That completes section 1. Try some homework. If you have any questions, please email me.